Hey guys, today I'm going to show you how we can set up a CI/CD pipeline on AWS, as well as set up a Kubernetes cluster on there and deploy a Helm chart. We're also going to expose our Kubernetes cluster externally using an application load balancer configured inside of AWS. Now the project we're going to be following along with in this video is from my NestJS Microservices Udemy course. So if you'd like to get access to that and follow along with the source code, I'll leave a link in the description where you can check it out. However, everything we go over in this video is going to be very generic, so you can apply this custom CI/CD pipeline to your own Docker images and this Kubernetes setup to any of your Helm charts. Let's go ahead and walk through how we can do it, and I'll see you there. Let's look at how we can run our microservices on AWS. We're going to use Amazon EKS to run our Kubernetes cluster, as well as exposing an external load balancer so we can access our NestJS app. We're also going to set up a build pipeline so that our Docker images will be rebuilt and pushed to an AWS image repository whenever there is a new commit to our GitHub repository. So to get started, head to aws.amazon.com and you can click on log back in. From here, you can sign in if you have an account, or if you'd like to create a new account, follow through with these steps. So signing up for AWS will be free. However, actually running the EKS cluster will cost up to 10 cents per hour to run the cluster. And we're also going to be charged for the underlying compute that we use. So the instances that we're using, we're going to use T2 micros in this tutorial, which is a free instance type. So we can set this cluster up really cheaply and explore with it. However, you will need to associate billing details with your account. All right, so after you finish signing up, you should find that you're in this AWS management console. We're going to start off by setting up an image repository so we have a place where we can push up our built Docker images to. Let's go ahead and search for ECR, which stands for Elastic Container Registry, which as we can see is a fully managed Docker container registry. Now that we're at ECR, let's click Get Started to create our repositories. So we're going to go ahead and create private repository so that only we and our Kubernetes cluster can actually pull these images. We're going to create a repository for each one of our microservices. So let's go ahead and start off with the reservations microservice and click Create Repository. Let's go ahead and repeat the same process for our three other microservices: the auth microservice, notifications, and lastly, I'll create a payments microservice. So now we have repositories to push our Docker images to. Let's go ahead and give this a try locally on the command line to make sure we can correctly authenticate and push our images up. All right, so we're going to need the AWS CLI installed on our system to easily interact with the AWS console from the command line. So if you don't already have the CLI, go to aws.amazon.com/CLI, and then we can click on Getting Started. Here we can see how to install the CLI based on your operating system. So click on your operating system and follow these instructions to easily install the AWS CLI. So after you've installed the AWS CLI, you should be able to run AWS configure to set up new credentials. To get access to these credentials, go back to the UI console and click on your username in the top right corner and then click Security Credentials. From here, we'll scroll down until we find Access Keys and we'll click Create Access Key. We'll go ahead and continue using a root access key. In case you'd like to create a user with finer grained control over the permissions they have, you can create a new user in IAM, sign into that user, and then go back to create access key just for that user. In our case, we want our root user to be able to do anything with this access key because we are using it ourselves. So we'll go ahead and grab the access key and paste this in to the CLI. Then we'll copy the secret access key and paste that in as well. You can feel free to select whatever default region you'd like. I'm going to use US East 1, and we've gone ahead and correctly configured AWS CLI. Now let's go back to ECR And we can click on any one of these repositories, and in the top right we can click on view push commands to get a list of commands to actually build and push our image up. So let's copy this first command, which is going to authenticate our CLI with ACR by calling AWS CLI and then piping that to Docker login. So of course make sure you have Docker running on your system before we execute this. And then I'll paste this command in to go ahead and log in. Now after we've logged in, we'll go ahead and cd into our apps folder and then cd into reservations. We can copy the next command to build the Docker image and paste it in. Now we'll make a modification. We're going to specify that the path to the Docker files in our current directory, but we want this to be run from the root context, from the root of our project. All right, so once our image has finished building, we'll go ahead and then get this command to tag our image based off of our repository name. So we can copy and paste this command directly. And finally, we'll run this last command, which will just push the Docker image up to our AWS ECR repository. You can see that the push is progressing. So once the image has fully pushed up, we can refresh the browser and we should see our reservations image has pushed up with the tag of latest. So now we have the ability to push images up to ECR. Let's see how we can set up a CI/CD pipeline to automate this process for our remaining microservices and ensure we always have the latest code available in these Docker images. So we're going to define a list of steps how to automatically build our Docker images and then push them up to ECR. In order to do this, we need to create a new file called buildspec.yaml and make sure this file is in the root of our project. Firstly, we'll go ahead and define the version we're using. In this case, it'll be 0.2, and then we can define some phases for our build. The first one will be a pre-build phase, where we will execute a command section, and in here we'll have a list of commands. So the first command we'll need is to actually log into ECR. We can take this command from our AWS ECR console where we click on View Push Commands and copy this first command where we get the login key and pass it to Docker login. So go ahead and copy this command and paste it in. So this is all we need to do inside of the pre-build phase. Next, we'll go into the actual build phase itself where we'll have another list of commands. And now we're actually going to execute the Docker commands to build and tag our images. So we can copy this first build command from ECR and paste it. We're going to specify the path to the Docker file will be in .apps/reservations/Dockerfile, and the build context, or where we want to build the Docker file from, will be the current root directory. So next we can go ahead and copy the command to tag the reservations image and paste it in. Notice we're using the latest image tag. So let's go ahead and copy these two commands, and then we can go ahead and just paste them in a few more times, and we're only going to have to change the service that we're building. So we're going to build the auth service and tag the auth service at tag latest. We'll go ahead and do the same thing now for the payment service. Make sure we go into /payments and make sure we tag the payments image correctly. Finally, we will tag the notifications image. So now that we've built and tagged our images, we're ready to actually push them up. And we'll do this in the final stage of the build. This will be the post-build stage, where we'll specify a new set of commands to actually push the Docker images to our repository. So we'll take the last command of Docker push, and then we'll paste this in a few more times, just swapping out the name of the image to auth, payments, and notifications. So now we have a completed build spec that will give CodeBuild the set of instructions it needs to properly build, tag, and push our images. So finally, don't forget to actually commit your change so that it will be available when CodeBuild scans our GitHub repository. So I'll commit a message saying add build spec and push this to my repository. So we're ready to utilize code build in that build spec to actually set up our automated builds. We're going to use CodePipeline to accomplish this, which will allow us to easily detect new commits and build them with our build spec. So look up CodePipeline in the search bar and click on CodePipeline. We want to create a new pipeline, so click Create Pipeline and call it whatever you'd like. I'll call this Sleeper. Next, we can select a service role, so click on Create New Service Role and use the default name provided and click Next. Next, we're going to go ahead and specify the source provider for our code. So in our case, this is going to be GitHub version 2. You can select which source provider you use. However, we're going to use GitHub. So in order to set up our GitHub provider, we need to create a new connection. So go ahead and click Connect to GitHub to set up a new GitHub connection. You can call this whatever you would like. I will call this the name of our app, Sleeper, and click Connect to GitHub. Next, we need to set up the GitHub app. So click on Install a new app to be redirected to GitHub and supply your credentials. You should be brought to this page where you install an AWS connector for GitHub. Go ahead and select the repository for your application. In this case, it'll be my Sleeper repository, and go ahead and click Install. After the installation, you should have a GitHub app pre-filled out of this form, and then we can click on Connect. We can see that our GitHub connection is ready to use, and we can select the repository from this drop-down. We can also select the name of the branch that we'd like to build from and watch commits. In this case, I'm going to use the main branch. And we will keep this box checked that will start a new pipeline on source code changes. Finally, for output artifact format, click on CodePipeline default and then click Next. Now we have to set up our build stage, and we're going to select AWS Code Build as our provider, and then we need to select a project in Code Build to use for this pipeline. In our case, we don't have one yet, so we'll click on the Create Project button and get redirected to Code Build. So now we're setting up a new Code Build project, and we can call this Sleeper as well. Then scroll down until you find the environment image. We will use an Amazon Linux 2 for our Code Build operating system. And for the runtimes, we will select Standard, and the image we will use AWS Code Build 86 by 64 Standard 4.0. Then click on the privilege box so that we can build Docker images and create a new service role for this code build. Then if we scroll down, we can see the build spec section where we specify the build spec.yaml. However, we can actually leave this blank because by default, it will look in the root for a build spec.yaml, which we have already provided. So we can continue down to the bottom and click Continue to CodePipeline. You can see we have successfully created the project in Code Build, and now we can click on Next back in CodePipeline. Then for the deploy stage, we are going to click on Skip Deploy Stage, and then click Skip. We can see all of the settings we have configured. Then we will click on Create Pipeline. Now we can see we are brought to the dashboard where we can see our source has successfully executed and our build stage is currently in progress. We can click on the details link, and then we're brought to the logs for the current build. In Code Build, you can see on the left side here, we are under the Code Build section. This is our in progress build, and we can click on tail logs to follow along with this build. It's currently in the pre-build section where it's logging in to Docker. And you can see an error has been thrown because the assumed role is not authorized to perform get authorization token on resource. This is because our code build service role we've created has not been given permissions to actually interact with ECR. Let's go ahead and fix this by going to IAM Service Console and clicking on IAM. And we can see our code build sleeper service role. Click on this role and then click on add permissions so we can add some new policies to this user. And then we're going to go ahead and filter out for ECR. We can see a pre-built policy here called EC2 instance profile for image builder ECR container builds. And if we open this up, we can see a list of permissions that allow this role to actually push images up to ECR, including that get authorization token permission. So let's go ahead and click on this permission policy and then click on add permissions. Now you can see this code build role has the ECR permissions it needs, and we can go back to CodePipeline to re-trigger a new release. To trigger this release, we'll click on our pipeline and then click on release change and then click on release. You can see a new build is in progress, and we can click details and tail logs to follow along with this new build. After the build has finished completing and all of our images are pushed up to ECR, we can close this and see that the build was successful. And if we go back to CodePipeline now into our Sleeper pipeline, we can see that the source and build have both succeeded. More importantly, if we go back to ECR now, all of our services have a latest image pushed up to them. This latest tag has been pushed up from code build. So now we have our images automatically build anytime we make a new git commit and push that up to our repository, which is great. Next, let's look at how we can run our Kubernetes deployment on Amazon EKS and provision a load balancer so we can access this cluster externally. Okay, so to create our EKS cluster on AWS, we're going to use a command line tool called EKS which is the official CLI for Amazon EKS, and will allow us to easily create and manage our clusters from the command line. So to get started, let's click on the introduction page, and we are at eksctl.io. Click on introduction, and then on the right here, let's click on installation to find out how we can install eksctl. So you can see for your operating system, we have different installation commands. Here is for Windows and for Unix. So go ahead and copy and paste these commands into your terminal to make sure you have eksctl properly installed. So after you have it installed, you should be able to go to your command line and run eksctl get clusters. And this is going to use the default AWS credentials we set up at the beginning. We want to go ahead and define a new cluster config file in our project that will define how our cluster is created. So if we go back to the documentation and go to the home page, we can scroll down until we find a default cluster.yaml file. Let's go ahead and copy this, and then we can go back to our root project and create a new cluster.yaml, and I'll paste in this cluster config where we can change the name to be called Sleeper, and I'm going to change the region to be closest to me, which is US East 1. Feel free to use whichever region you would like. And then importantly, we have different node groups defined, and this is going to be the nodes we have available to run our workloads. In our case, we only want to run one node group, so we can call it ng1, and we want to change the instance type to a T2 micro instance. This type of instance is available on the AWS free tier, so we won't be charged for its usage if we don't go above the default CPU limits of 750 burst hours a month. We can also specify the number of nodes we want to have. In this case, we can just keep this at 3. So now we have this cluster defined. We can run eksctl create cluster, and then provide --config, and then provide -f, and then provide the cluster.yaml file. And now eksctl is going to execute tasks through CloudFormation to create our cluster. So go ahead and let this command finish. It might take some time to create the cluster. So after some time, we can see that our EKS cluster has finished creating, and we can see this note here that our kube config has been updated automatically. So now we can run kubectl get nodes, and we can see the 3 nodes that have been provisioned in our cluster. We can run eksctl get node groups and specify the cluster is Sleeper to see the current node groups in our cluster, and we can see the size is at 3. Okay, so now we're ready to actually install our Helm chart into our EKS cluster. Firstly, we need to make an update to our Helm chart to point our images at our ECR repository. So let's open up our build spec, and then let's copy the name of the reservations image, and we'll go into our K8's Helm chart and open up our templates folder, reservations, deployment, and then we'll go ahead and swap out the image to be pointing to ECR now. Let's go ahead and do the same thing for auth. We'll copy the tag and swap this in for the image. We'll grab the payments image and do this for the payments deployment as well. And finally, we will grab the notifications repository and swap out this image. So before we deploy our Helm chart into EKS, we need to provide the secrets needed for our deployments. The easiest way to do this is to run kubectl config, use context, docker, desktop, and switch back to our local Kubernetes cluster. We can of course now run kubectl get secrets to see our secrets that we've created previously that needed for our deployment. So now I'm going to run kubectl get secrets and output this to YAML and pipe it to a secret.yaml file. Then I'm going to open up the newly created secret.yaml file, which is just going to be a temporary file. And I want to get rid of the GCR JSON key. So let's remove this first entry here so that we just have the other secrets that we want to carry over. So now let's run kubectl config get context to get all of the context in our system and our Kubernetes clusters. And I want to copy the context for our EKS cluster. So copy this one, and then we can run again kubectl config use context and paste in our EKS context. So now we can again run kubectl get nodes and see our EC2 instances again. But now, importantly, I want to run kubectl create -f for file and apply the secret.yaml we've created. And now all of our secrets will be created. Then I'll go ahead and make sure we delete this temporary secret file so we don't expose these secret credentials. Now that our images have been updated, we can cd into our K8s folder and then cd into the sleeper directory. And now we're going to run helm install sleeper and specify the path is the current directory to the Helm chart. Now you can see that our deployment was successful. So after giving our Helm chart a little bit of time, we can run kubectl get pods and see that all of our pods are in a running state. We can then get the logs of our reservations or any one of the pods and see that it has fully started up and is listening. Next, let's look at how we can provision a load balancer to expose an externally available URL that won't change. So a quick note, if you run a kubectl get pods and you find that some pods aren't starting up because of the fact that there are not enough nodes available, we can easily scale up our existing node group by running eksctl get node groups in our cluster of sleeper. And then we can say eksctl scale node group ng1 and set -n to 5. You can see that our max size also needs to be updated. So we can provide a -M5 to increase the maximum number. So in order to provision a load balancer in EKS, we're going to use the AWS load balancer controller, which you can find at kubernetes-sigs.github.io/AWS load balancer controller. Now, this load balancer controller is automatically going to provision an application load balancer inside of AWS anytime we create a service with an ingress resource. So to install this load balancer controller, we click on the deployment link and then click on configure IAM, scroll down to the steps to set up the load balancer controller, and we'll copy this first command where we associate an IAM OIDC provider and go ahead and paste this in. We just need to change the name of our cluster to be the one that we are using. In this case, I'm using the sleeper cluster, and then we'll change the region to whatever region we're using, in this case, US East 1. Next, we're going to download the IAM policy based on the region we're in. So we have one for the US government cloud, China, and all other regions. So I'll copy the all other regions, curl this, and download it to the current directory. And then we create a new policy based on this downloaded file. So copy this command, paste it in, and enter to create a new policy. Finally, we want to create an IAM service account using this policy. So paste this final command in to have EKSCTL take care of this for us in creating an IAM service account. So we need to provide the region like we just did before. So this would be US East 1 for me. And then importantly, we need to provide the AWS account ID associated with our account. So in order to get this, you can go back to the AWS console, go to the IAM dashboard, and copy the account ID in the right here. And then go ahead and swap this out in this command. Finally, we need to provide the name of the cluster we're installing this into. As we've done before, this will stay the same as Sleeper. So enter this and let EKSCTL roll out a CloudFormation to create this. So finally, we're ready to actually install the load balancer controller. So scroll down to the summary where we get the first command to add the Helm repository and paste this in. Now that we have the repository, we're going to go ahead and apply the Helm chart with this next command. Now finally, we can actually install the Helm chart. So we're going to copy this command for clusters with IRSA, copy this command, and now paste it in. Of course, we'll need to update the cluster name as we've done before. So go ahead and update that to Sleeper. So go ahead and swap this out to our cluster name of Sleeper and let this Helm chart install. Now, if we run kubectl get pods in the kube system, we can see two load balancer controller pods running, and we can run kubectl logs in the kube system and follow this to get some logs, and we can see that the load balancer controller is up and running and watching our services now. So back in our Helm chart, we can remove this temporary IAM policy we created. Now finally, in order to tell the load balancer controller about our ingress resources, we need to include some annotations on our ingress. So let's add a new annotations section here where we define two new annotations. The first of which is going to be alb.ingress.kubernetes.io/scheme internet facing to make sure that this load balancer is attached to a public subnet that is externally facing. And then we provide the Kubernetes ingress class ALB to provision an application load balancer. So let's go ahead and save this, and then we can run helm upgrade sleeper and provide the root path here. Now we can run kubectl get ingress, and we can see that a new address has been provisioned for us. It will take some time for the application load balancer to get provisioned, and we can even check the status in AWS by going to the EC2 dashboard and then scrolling down to load balancers. And then we can see our application load balancer that is in a provisioning state. So let's go ahead and let this finish provisioning. After a little bit of time, we can see the status has now switched to active. So if I copy the DNS name now, we can then open up Postman to test out this load balancer. So now in Postman, if we enter in our load balancer URL and enter /reservations with a trailing slash and send off this request, we get a forthly response back from our reservations deployment, which is great to see because we're not passing in any GWT information, but we are able to reach our application externally from this URL, which is great to see. Now we have a way to provision an external load balancer and expose our application externally.